This conference will now be recorded.
Everyone, guys, please take care of your mic. Keep it off. Okay, so good evening, everyone. So, I'm sorry. So, we completed in the last session, we completed the topic storage classes. We saw how to use the internal double EEPROM. Now, today, let's start with the next topic, which is nothing but the communication protocol. So, people, so we completed almost 80% syllabus. Just communication protocols are pending. So, if you are lagging, if any assignments are pending, please speed up. Okay, so try to complete at least 2 assignments per day, or if not possible, try to complete 1 assignment per day. Fine. So now today we are going to start with the communication protocol. So here what we are going to do, first we are going to see the introduction related to the communication protocols. Then in this course we are going to study this protocols: UART protocol, SPI, I2C, and CAN protocol. So everybody please pay attention. Let's start with the introduction. So people, in the introduction few questions are there, we have to understand. So first question is saying, what do you mean by communication? So people, in general, can you tell me what do you mean by communication? What is communication? Are we communicating now? Yes, give me the answer in simple term. Yes, what is a communication? Correct. Very good answers. It is what? Exchange of information. Yes, it is a transfer of message. Correct. So can I say, as you said correctly, it is what? Exchange or transfer of, instead of saying message, I will say information. Correct. So it is nothing but exchange of information, but you have to exchange that information at least between two parties, right? So it is nothing but exchange of information between two parties. So what is a communication? It's a exchange of information between two parties. So we humans, how do we communicate? So we do speak, we write, we use the sign language, and we communicate, right? So guys, what happened? We communicate. Why do we communicate? We communicate because we have a need of it. Correct. So otherwise what happen, if we are not communicating, sometimes we feel bored, all right? Otherwise there is a need of communication, that's why we are communicating. So people, let's take current example. Are we communicating right now? You people and me, are we communicating right now? Yes, we are communicating, right? So there is a need of communication. You want to learn this course, that's why we are communicating. So we humans communicate because of our need. But what about systems? What about machines? Why do systems communicate? Why communication is required between two systems? Why communication is required between two machines? Now, to understand this question, let me take one example. I think I already took this example, but let me take once again. Let's say I am developing a system or automatic water pump or water pumping system. So I have a farm for the watering purpose of for the to watering the farm. What I'm doing, I'm designing automatic water pump system. Guys, if is there any type of mistake, please ignore that. Designing what? Automatic water pumping system. So every day what I wanted to do, daily at 8 o'clock I wanted to start the pump for the 1 hour. So how this application we are developing? Let's say I want to have a microcontroller. So for this application, let's say I'm having a microcontroller. Okay, and to this microcontroller, so it can be any microcontroller, doesn't matter which microcontroller you are taking. Let's say, so here this microcontroller is connected to the relay. So relay is kind of driver, right? And then further to this relay, pump is connected. Okay, so what happens? So directly relay is connected to the microcontroller, and further to this relay, pump is connected, and based on the relay logic, it will be on or it will be off. Now people, what is the requirement? I wanted to design automatic water pumping system which will turn on the pump daily at 8 o'clock. So once it is 8 o'clock, microcontroller will inform to relay and relay further will turn on the pump. So what happens? So guys, I have a microcontroller. Don't you think it has to maintain a real time? Correct? So I want to start the pump 8 o'clock. So I connected my microcontroller to the relay. So I want to start the pump exactly at 8 o'clock. So what you have to do for that, you have to maintain your microcontroller real time. Means it has to keep calculating a time. So now you may say, ma'am, we already studied the timer. We know how the timer is using. So microcontroller is having built-in timer. Why can't you go with that? Okay, so let me pick the built-in timer. So what happened? So this timer is counting the time. Okay, fine. So timer is counting the time. So whenever there is 8 o'clock, relay is connected to the microcontroller via relay. Pump is going to start every day at 8 o'clock. Okay. But guys, thing is what? This system I install in my farm. And let's say my farm is located in the remote area. So am I going to have power 24 by 7 there? Power is always going to be there in my farm. In my agricultural land, there is going to be power every day 24 by 7. No, right? Power loss is going to be there definitely. See, a lot of remote areas there in our country. There, do we have a power every day 24 by 7? No. So, people, what happened? Let's say if there is a power failure, let's say power failure for a 1 hour. So, if power fails, then this microcontroller is going to run? No. If no power, microcontroller will not run. If microcontroller is not running, then timer is going to run? No. So it is not going to count the time. So guys, don't you think then my pump is not going to start at 8 o'clock? Right? Am I able to start the pump at 8 o'clock? If there is a power failure, do we? Is microcontroller exactly going to start the pump at 8 o'clock? If there is a power failure, no. Whatever power fail, whatever that timing is there, that time is what? Missed by the timer. So obviously there is going to be lag, some lag, correct? So what we have to do? So we have, what is the solution for that? What is the solution for that? So if power fails, we need to make sure my system is still running. So I can run my system on what? What we can provide? So can we provide some battery backup? Yes, we can. So what happened? So if power fails, so for that purpose, I will provide a battery backup. So what happened, people? If there is a power, my system is going to use that power. And if power fails, what happened? My main system, my microcontroller is going to use the batteries. Okay. Now people pay attention. Now just to retain a time, what am I doing? I'm powering complete controller. I'm powering what? Main system itself. It has many drawbacks. Now people, what happened? Your controller, your microcontroller unnecessarily working just to retain a time, just to make sure timer is running and it is counting a time. For that, your microcontroller is what? Unnecessarily keep running. So since what happened, this power is coming up from, let's say, you're using the batteries. So guys, don't you think since you're powering your main system, don't you think it will be drawing more power? Right? Don't you think these batteries will drain out within a few months or within a few days only, since you are powering the main system? Correct? So guys, so what we can do, what is a solution for this? So what we can do, let's offload the microcontroller. So what we will do, let's offload. So we will offload our microcontroller, or you can say we are offloading our main system. So I'm offloading a microcontroller. So how I can do offload my microcontroller? So instead of giving a load of calculating the time to my microcontroller, I will offload my microcontroller and I will use a external chip, which is nothing but the RTC. RTC stands for what? It's a real-time clock. It can also maintain a time. And biggest advantage of RTC is what? This chip can be separately battery powered, and it draws what? Very less ampere of current, very less ampere of power. I think it is using what? Just a few microamperes of current. So whatever battery is connected, those batteries goes for the years. Okay, so our biggest problem is solved. Okay, so I'm using the RTC. So RTC is counting a time, so our biggest problem is solved. Now I'm not going to see here, I'm not overloading my microcontroller just to retain a time. So who is retaining the time now? RTC external chip is what? Retaining the time. But question is, who wants to start the pump? People, who wants to start the pump? Who wants to start the pump? RTC or microcontroller? RTC is maintaining a time, but who wanted to start the pump? Microcontroller wants to start the pump, right? But now microcontroller doesn't have a time, correct? Who is having time? RTC. So what can happen, people? If required, RTC can generate an interrupt. So you can use RTC, turn on RTC, and you can say to the RTC, once there is 8 o'clock, you send the interrupt to the microcontroller. So like this way, what happened? My RTC is what? Sending the interrupt to the microcontroller. So now, people, if this interrupt is received by the RTC, that time this microcontroller might be busy in some another task, or it might be sleeping. Let's say this microcontroller is sleeping. So usually, people, let's take our scenario also. Let's say you're sleeping and somebody is interrupting you. Then what you will do? You will ask, no, why are you interrupting? I'm sleeping, right? So let's say this microcontroller also sleeping, and as soon as it got the interrupt from RTC, then what it will do? What it will do? It will go and query to the RTC. Why are you interrupting me? Then RTC will what? Respond back. It's 8 o'clock. You want to start the pump. You can start now. So guys, don't you see here? These two chips, these two systems are communicating right now. Yes or no? Do you see there is a communication is happening between microcontroller and between the RTC? Understanding? Yes or no? So guys, question was, doesn't matter how many ways, let's not include that, Vivek. Just they are communicating. Okay. So people, what was my question? My question was systems, chips, or machines, why they need a communication. Now, answer for this is what? What happens sometimes if you are overloading your main system. Now, let's say if you keep overloading your microcontroller in this case, then what happens? It will not work efficiently. This is not efficient usage. So what you are doing? You are offloading a microcontroller. So RTC is what? Calculating a time. And if that work is done, RTC has to communicate with microcontroller, or microcontroller has to communicate with the RTC. So that's why communication is required between the system. Understanding? So what happened? So if you are overloading in main system, efficiency goes down, correct? So that's why you are not overloading that system. You are giving work to somebody else. When that work is done, those systems are communicating. Getting, people? Yes, no? Okay, now next question is about different modes of communication. So people, you already know the answer of this question. What are the different modes of communication? So guys, I'm just revising it. I'm just creating your base for the learning further protocol. So pay attention, everybody. So can you tell me what are the different modes of communication, people? People? Quickly, can you give a try? Can you try to answer? It's okay even if your answer is wrong. SPI is a protocol. I'm asking mode of communication. Very good, Nijagunappa. Okay, one way, two-way communication. But what it is called? I'm looking for that particular term. Yes, Harish. Whatever Harish is saying, correct, people? Simplex communication. Okay, so let me go ahead with the first mode, which is nothing but the simplex communication. So, guys, what do you mean by simplex communication? May I know what do you mean by simplex communication? Come on, you all know these things. If communication is happening in one direction, if your communication is what, one way communication, okay, let's say communication is happening between two parties, then what, if one party is transmitting, other will just receive it, it's just a one way communication, other party can't respond back, right? It is a one way communication. So guys, for a one way communication or for a simplex communication, can you give me the simple example where one way communication is happening? Very obvious and very simple example. Can I get it from your side? No, Harish. Walkie talkie is not doing one way communication. Very obvious device. Can you give me the very obvious device which is designed for the one way communication? Simple people. Yes, you can go with what? Broadcasting, whatever happening on TV, or you can take a example of radio, or even you can say TV, right? So guys, whenever any broadcasting is happening on radio or on TV, it is just a one-way communication, right? We are just listening that. Yes or no? Fine. So this is about the simplex communication. Then next is nothing but half duplex communication. Okay. So what do you mean by half duplex communication, people? Answer. It is what? How many ways communication it is? It is two-way communication, right? But what is the restriction? Correct. Two-way communication, but one party can communicate at a time, right? One at a time, correct? Means let's say right now we people are communicating, we are doing two-way communication, but if I'm communicating, you are just listening, and if you are means if I'm speaking, you are going to listen, and if you are speaking, I'm going to listen. Two-way, but only one at a time. So very obvious example of this is nothing but what? Walkie talkie. So walkie talkie comes under this, it is used for the two-way communication, right? So now what happened, people? I don't know whether you use this walkie talkie device or not. You might be at least seen in some series or in movies, right? Usage of walkie talkie, right? So what happened, let's say if one person is speaking, then what, other one will listen, right? Then if other one has to speak, then it will press some button, and what, that person is speaking, then what, first part is just listening, correct? So walkie talkie, yes, it is doing two-way communication, but one at a time. Fine, nice. Okay, then third mode of communication is what? It's a full duplex communication. Okay, so can you tell me, guys, what do you mean by full duplex communication? It is how many ways communication? Yes, it is a two-way communication. So do we have any restriction like a half duplex? No. So it is two-way communication, and both parties can what? Communicate what? At the same time, or I would say two-way communication, both parties can communicate simultaneously. Yes or no? Mm-hmm. Yes. So what is example? So example of this is nothing but what? Correct. I already got one example, your mobile phone. So whatever calling you do on mobile phone, it is what? Two-way communication. Both parties can communicate, right? Or by using go-to meeting, we are communicating right now. It is which way communication, people? It is comes under which? Simplex, half duplex, or full duplex right now. Whatever communication we are doing, it is what? Yes, it is full duplex communication, right? So I told you, I force you to turn off your mics, right? Otherwise, what you can do? We both can speak at a time, correct? Two-way communication can happen at a time, yes or no? Fine. So this is about what? Different modes of communication. Understood, people? You know these things. I'm just revising. So this is going to be base when we are studying the actual protocols. So there I will not repeat all these things. Huh? Understood, guys? Clear? Any query here? Okay, then next question is about different types of communication. What are the different types of communication? So guys, can you please try to answer this question? What are the different types of communication? Modes we saw. Now we are talking about the different types of communication. What are those? One bit is getting transmitted at a time. Multiple bits can be transmitted. What it is called? I'm giving you some hint. Yes, so you can have a serial parallel communication. What else? What else? One starting with yes, another yes. You can have a synchronous. Give me a pair. Synchronous and asynchronous communication. What else? Are there a lot of types are there? What are those? Okay, fine. So serial parallel communication, synchronous or synchronous communication, even you have a wired wireless communication. But people, I will not pick that category because whatever protocols we are going to learn here, all are the wired protocol, no wireless protocol. So this types you need. So let me revise this, huh? What you know about this. So let's talk about the serial parallel communication first. Now, people, in case of serial communication, how many bits are getting transmitted at a time, at one instant? How many bits are getting transmitted? One bit, only one bit, right? It is a bit by bit communication, correct? So, what is happening? Per instant, one bit is getting transmitted. And in case of parallel communication, how many bits are getting transmitted? All the bits, okay. So instead of saying all, multiple bits is good word actually. So can I say n number of bits are getting transmitted? So n value could be what? More than one, correct? N number of bits are getting transmitted. Which one is faster, which one is slow, people? Obviously, among serial parallel, which one is slower? Yes, this is slower and this one is faster, right? Okay, fine. Okay. Okay, now this is about the serial and parallel communication. In case of serial, one bit is getting transmitted per instant. In case of parallel, n number of bits. And could be what? More than one. So parallel communication is faster than the serial communication. But unfortunately today, people, we are bothered or more concerned about the form factor. So form factor means what? If I'm using parallel communication, so don't you think number of lines are going to be more? Let's say my n value is 8. N bits are getting transmitted per instant. Then what happened? On my hardware, at least I need 8 lines, 8 number of wires. So here number of wires are high. That's why people are going with the serial protocols now. So serial protocols are what? Most dominating protocols nowadays. So parallel protocol you will not see much. Where faster communication need, there only parallel protocols are there. For example, when you want to fetch the instruction or memory communication of with respect to memory or CPU, there you can see parallel protocol. But otherwise, what happened? people are what going with the serial protocol. These are the most dominating protocols nowadays. So today here, or not only today, so that's why whatever protocols we are going to see here, all the protocols we are going to learn here are the serial protocols, no parallel protocol. Okay, so what is a serial protocol? Bit is getting transmitted, one bit is getting transmitted at a given instance of time. It is called as the serial communication or the serial protocol. And people are what concentrating too much on serial protocol. So these protocols also becoming faster nowadays. Okay, faster today. So this is about the serial and parallel communication. Then another type what we need to understand, at least you should have an idea about synchronous and asynchronous communication. So people, in case of synchronous communication, communication will happen with respect to which signal? Aniket, let's not bother about the example. We are going to see four protocols which comes under serial or parallel, synchronous, asynchronous. We will see those. Fine. So communication will happen with respect to what in case of synchronous? Communication is going to happen with what? Clock line, clock pulse with respect to clock signal, correct? With respect to every clock pulse, bit is getting transmitted, yes or no? And in case of asynchronous communication, is there any clock line? Is there any clock signal? So asynchronous communication will not have a clock line. Correct? No clock line. So in case of asynchronous communication, happen with respect to some trigger. So first it has to generate a trigger and get the attention of receiver, and then communication will happen. So this is about the synchronous and asynchronous communication and serial and parallel type of communication. So any doubt here? Anyone having any query? Still now, whatever we studied in that, do you have any query? Respond quickly, people. If you have a question, let me know. If you don't have, let me know. Okay. So now, let me go to the next point. 3 points we covered. Next one is about why protocols. Why do we need a protocols in communication, or why do we need to follow the protocol? So before answering this question, why protocols, so let me ask you this question. What is protocol? May I know what is protocol? Yes, standards, or it is what? Set of rules, correct? Nice. What is a protocol? It is nothing but set of rules which we are going to follow, is nothing but what? Protocol. Okay. So now why protocols needed? Why do we want to follow the protocols? By the way, people, we humans, do we follow protocols? We humans, whatever protocols set by our government, by our society, do we follow those protocols? Yes, no? Yes, okay. Don't be biased while answering. Answer honestly. If you ask me, sometimes I follow, sometimes I don't, right? Yes or no? It's as per our comfort. Correct, people? Sometimes we follow, sometimes we don't follow. I hope everybody agree with me. Now, guys, now question is, why do we want to follow protocols? Now, let's imagine, people. Imagine if I take this class in my mother tongue, what will happen? Let's say my mother tongue is Marathi language. If I started taking this class in my mother tongue, then what? How many people will understand? Probably nobody will understand the class, right? So if required, I can what? If required, what? I can take a class in Kannada. Even I can take a class in Hindi, or even I can take a class in Marathi. But why English? Because it's common protocol. We know in India there are different types of people, different languages are there. So by following protocol, what? Things go perfectly fine. Communication become reliable. That's why to make sure things are going fine, to make sure reliable communication is happening, we have to follow the protocols. But by the way guys, it's not a matter of humans, we are not talking about the humans, it's a matter of machines, it's a matter of system. So systems how to talk with each other. And how do they talk with each other using what? Pulses or signals, right? So those pulses, those signal has to be interpreted on common platform. So there should be some rules. There should be some rules for what? How do I send the signal? How do I receive the signal? That's why we have to follow the protocol. So by following the protocols, communication become reliable. That's why there is a need for following the protocol. That's why we need to follow the protocols. Understood this question? Why we need to follow the protocols, people? Okay, now guys, today it is happened that some big companies created some protocols and those protocols become very famous. What are those protocols? You can see list is here. So if you ask me who created this UART protocol, UART is by Intel, SPI is by Motorola, I2C protocol is by Philips people, and CAN protocol is by Robert Bosch. So these companies created these protocols. So here in our course, we are going to learn this protocol. So before going into the protocol, what we will do, let me introduce one concept. Then we will start with the UART protocol. So what is that concept? Now let me talk about the interboard and intra-board protocols. What are the interboard protocols and what are the intra-board protocols? Okay, so two types of protocols are there again. So you can see you are having what? Interboard protocols. Okay, so again in this interboard protocols, if you are asking me the example, your UART protocol and CAN protocols comes under the interboard protocol. And another category is nothing but the intra-board protocols. Okay, so in this intra-board protocols, you are having SPI or this I2C or I2C protocol. Fine. Okay, so these are the intra-board protocol. So what do you mean by interboard? What do you mean by intra-board protocol? So guys, let's talk about the interboard protocol. So guys, if communication is happening between two different boards by using a protocol, then it is what? Interboard protocols. So if you're communicating between two different boards, let's say this is my PCB1. By the way, what is a PCB, guys? Let's say this is my PCB1 and this is my PCB2. So PCB is nothing but what? Printed circuit. PCB is nothing but what? Printed circuit board, correct? So guys, when communication is happening between two different boards, two different systems, then it is what? Interboard protocols. It is what? Interboard communication. So by using a UART and CAN protocol, you can communicate between what? Between two different boards, between two different systems. Okay, and what do you mean by intra-board protocol? So intra-board protocol means what? You're having only one board. Okay, let's say this is my PCB. So on a single board, if you are communicating between two different chips, between two different ICs, then it is what? intra-board protocol. So let's say, so this is what my one board. So on a same board, I have a two chips, and if I'm communicating between these two chips, between these two ICs, then it is what? Intra-board communication. So SPI and I2C protocol support this type of communication. So you might be having what? Two ICs, two chips on your board. Let's say this is what? Chip number 1, and this is what? Chip number 2. So on the same board, if you are communicating between two different ICs, two different chips, then it is what? It is what? Intra-board communication. Okay. I hope you are getting it. Fine. So now let me show you this intra-board at least example. Now see here. So this is what my single board. Correct, people? So now you can see this is one chip. What it is? The microcontroller. And let's say this is another chip. It is what? RDC. So if I'm communicating on the same board, if I'm communicating between these two chips, then what kind of communication it is? It is a intra-board, which I can achieve by using SPI or I2C protocol. Understanding? So even you can communicate between EEPROM also here also. Even if you are communicating between these two, it's a intra-board communication. And if communication happening with two different boards, then it is what? Interboard communication. Understood? So these concepts are important. In your interviews, you may get the question, what is interboard communication? What is intraboard communication? What are the protocols related to that? Understanding. So you should know this concept, because tomorrow, as a design engineer, let's say you want to communicate between what two different boards, and then you are selecting a intraboard protocols. Is there any use of that? No, you have to go with what? Interboard protocol. So these concepts are important. Understood? Clear? You have to pick the protocol, which type of communication you are doing. Based on that, you have to pick the suitable protocol. Okay. Fine, people. Understood? Okay. So this is about the introduction to the communication protocols. Okay. Now let's start with the very first protocol, UART. So who created the UART protocol? Just now I said, do you remember? UART is by whom? UART is by Intel. Correct. So now UART. UART stands for what, guys? UART stands for what? Universal. No idea? Nobody? UART stands for what? Universal Asynchronous Receiver Transmitter. Correct. So UART stands for what? Universal Asynchronous Receiver Transmitter. Or even you may see this term frequently, UART also. So what is a UART? UART is nothing but universal. Let me note down this first. UART. U stands for universal. S stands for the synchronous, and A stands for the asynchronous communication. So UART is what? Universal synchronous communication. And I don't know why I'm saying synchronous. I'm so sorry. UART stands for what? Universal Asynchronous Receiver Transmitter, and UART stands for Universal Synchronous Asynchronous Receiver Transmitter. So basically, by using a UART, you can do the both modes of communication. You can use a synchronous mode also, you can use a asynchronous mode, but only one mode at a time you can use, but it support what? Synchronous and asynchronous communication. Okay. So now people, here in our case we are going with the UART communication. Fine. We are using asynchronous receiver transmitter. Fine. Okay, so let's go here. So under this protocol, we are going to study introduction to the UART, interface we will see, then hardware configuration we will discuss regarding this protocol, and finally what is frame format of UART protocol, we will discuss that. Okay, so now let's start with the introduction. Now people, I will not invest much time here. So it is what now somebody was asking example na. So UART is what type of protocol, what communication it support? It is support asynchronous communication, right? It is what support for the asynchronous communication. So if it's a asynchronous communication, that means which line is absent here? What is not available? Clock line is not there. Clock line is absent here. So communication will not happen with respect to clock because it's a asynchronous communication. Then duplexity. If you are talking about the duplexity, they are saying any means it support what? Simplex mode of duplexity also. It support what? Half duplex also. Okay. And if required, it support what? Full duplex also. So it support what? Any kind of duplexity. So which one you have to use? For that you have to open a data sheet and you have to go ahead with that. So here you are having simplex, half duplex and full duplex, more duplexity. Okay, and then master slave. So but we don't refer the term master slave for the UART. So instead of that we are referring the term as a host and device. What term is used instead of master and slave? It is used as a host and device. Host is the one which is going to control the device by sending all the commands. Okay, so instead of master slave we are saying this as a host or device. Fine. Okay, so usually this UART protocol is used for what? Point to point communication. Now people, if you're talking about interface, okay, then what? It's a asynchronous, so there is no clock line. And if you see the duplexity, it supports simplex also and it supports full duplex mode of communication also. Then guys, if you're having full duplex mode also, then minimum how many lines do we need for communication? Full duplex means what? Two-way. You can transmit and you can receive at the same time. So how many lines you need? Two lines you need, right? Via one line you can transmit, via another line you can receive. Two lines are there. Now if you see the hardware configuration, let's say these are the two devices, okay? So from this line, device 1 is transmitting, device 2 is receiving. And via this line, device 2 is transmitting, device 1 is receiving. So you are having two lines. And apart from this, there might be what? Common ground. Okay, so this is what? Hardware configuration. Clock line is not there, right? Okay, fine. So now next slide is talking about the, I think, frame format. This is very important slide. So in this pattern, data is getting transmitted. So what I will do, I will explain this here. First, I will let me take this window. Let me explain here. Okay. So let's say you are doing communication between two devices. Okay. So UART is what kind of protocol? Interboard or intraboard protocol? It's a interboard protocol, right? So you can communicate between two different boards. Now let's say you can communicate between two different devices. So let's say this is my device one. Let's say this is another fellow device two. Now see what happened. Device, let's assume device one. I'm trying to keep things very simple. Let's consider things very simply. So let's say device one wanted to transmit some data to the device two. So what data? Let me take an example of data. Let's say 0x25. Okay. So this data, device 1 wants to transmit to the device 2. So what is the binary of 0x25 people? 0010, right? And 5 is what? 0101. Am I right? So if you observe in this data, what is happening? This is what your MSB bit D7, and this is what your LSB bit, which is nothing but the D0. Correct? Yes or no? Fine. Now let's assume. So communication. Okay. So this device 1 wants to transmit the data to the device 2. Now let's assume device 1 started transmitting the data. Now before that, my question is, UART is what kind of protocol? Serial or parallel? What I told you, all serial protocols we are having. So it's a serial protocol. So in the serial protocol, how many bits are transmitting at a time? One bit, right? It's a bit by bit communication. See guys, I already created your B sum. So now you have to answer. Okay, so what happened? I'm sorry, your transmission will happen from the LSB. So first it is transmitting D0, then it is transmitting D1, and D2, like this way it will keep transmitting the data. But people, when this device when it's transmitting the data, that time, what if this device is doing some another work, or what if this device is sleeping? What happen if this device is sleeping? It is going to receive that data if it is this fellow is sleeping? Obviously no, right? So people, don't you think before we start the communication, see here it is what? Asynchronous communication. There is no clock line. So in case of asynchronous communication, before transmitting, before doing transmission, you have to get the attention of receiver. So how we can get the attention of receiver? So what happened? So here first bit which is getting transmitted is nothing but the start bit, not data directly. So which is nothing but the 0 in this case. So first what is getting transmitted? Start bit. So it will transmit the start bit. And what happened? This fellow device 2 will receive a start bit. So as soon as it receive a first bit as a 0, that is nothing but the start bit, it will understand, okay, somebody is trying to do the communication with me, I need to pay attention. So start bit is transmitted, and after that it will start transmitting the data. I'm sorry. So data will be transmitted from LSB. First D0 will be transmitted. Then what happened? It will transmit the D1, then D2, D3, D4, D5, D6, like this way. One bit is getting transmitted at a time. And the way it is transmitted, same way it will receive. So first D0 is transmitted. What happened? D0 will be received here. Then D1 will be received here. Then D2 will be received here. D3 will be received here. So like this way, it will receive a 8 bit up to D7. Okay. Now, now what happened? So it will what? Munir, let's keep the things easy. I will come to that point. So what happened? So it will transmit D0 to D7 like this way. Sorry, it will transmit D0 to D7, and like this way the bits are received here, D0 to D7. Okay, now people, and let's say I want to transmit just this 8-bit data. So after this data, this device 1 is having any another data to transmit? Is there any other data? As of now, do we have any other data to transmit? No. So guys, don't you think once you are done, don't you think you have to tell your device to, I'm done, I'm not going to transmit any other data, I'm done with the data, right? So what it will do, once it complete data, it transmitted the data, it will send the stop bit. So actually stop bits are 2 bits, which are nothing but the 1. It will generate two stop bits continuously, 1 1. So as soon as it receives the stop bit, it will understand, okay, I got the complete data from the device 1. Okay. Fine. So up to this, are you able to follow me? Up to this, whatever I'm saying, are you able to follow me? Okay, now what happened? So this device 2 is receiving the data. Okay, but what about this data integrity? How this device 2 is going to conclude? Whatever data I received, it is correct or not? How it is going to conclude? So what happened? So for that, actually in the frame, one more bit is there for the data integrity, and that bit is called as a parity bit. So what you are having? You are having one more bit, which is nothing but the parity bit. So people, so this parity bit comes after the D7. So what happened? So this device 1, based on your data, calculate the parity and transmit. So you are having two types of parities. One is nothing but the odd parity, another is nothing but the even parity. Okay. So what happened? Whatever data you are transmitting, you count number of ones. If your number of ones are odd, okay, you're counting a number of ones, and those do that. If number of ones are odd, count of number of ones is odd, then what you can do, you can say it's a odd parity, and you can set your parity bit as a 1. So you can count the number of ones. If number of ones are odd, you can say p equal to 1. It is nothing but or parity. An opposite case is what? You keep counting the number of ones, and if count of number of ones is nothing but the even. If you have a count even, then what is your parity? It's a even parity. So you can set the parity bit as a 0. Okay, parity bit will be 0. I'm sorry. Now people, in this case, what is my parity? Even or odd? What my device one, what my transmitter will transmit the parity? It is even or it is odd? How many ones you are having? 1, 2, 3. So odd parity. So what happened? Transmitter, based on the data, calculate the parity bit. So in this case, it is odd parity. It is 1. So it will transmit the 1. And the same way, it will receive the parity bit, which is nothing but the 1. Okay, so now people, what happened? Now, how this parity bit is used by the device to for data integrity? So, what happened on arrival of the data? What happened? The way transmitter calculated the parity bit, the same way receiver will also calculate the parity bit. And if that parity is matching with received parity bit, then it will conclude the data is correct. Otherwise, it will say I got the corrupted data. So based on this parity bit, it is getting decided whether it is correct data or whether it is corrupted data. So that's how data integrity is achieved by using the parity bit. Getting? Now you see this. Okay, so Munir, your concern was this? Yes, whatever you are saying is correct. You see here, correctly I'm writing everything here. So first, whenever communication you want to do, so initially the signal you have to change from high to low. That is nothing but the start bit. Then you are having a data bits D0 to D7. Data bits could be 1 or 0. And then you are having parity bit, it is 1 or 0. And then at the end, we are having two stop bits which are nothing but the 1. Okay, so any doubt still now? This is how Intel people design, Aniket. So whatever designed by the Intel people, we are learning that. So they are considering 2 bits for the stop. Those are nothing but high, 1 1. Mm, pulled up means in which sense you are saying pulled up? Munir? Yes, it's a high. Okay. See, thing is what? Okay, to be honest, I don't want to go in detail because I'm sorry. So whenever we are doing programming, I'm not talking about the this one. I'm not talking about how it is designed internally, how the connection is done. So for that, you do one thing, you open a data sheet and you go through the circuit diagram. So my concern is what? I'm not going to use the circuit and I'm not going to teach here how to do the designing. So if you're interested, you go through this. If you have any doubt in that, you let me know. So now we saw the frame format. So frame will be in this format. So when we are doing communication, that time you should have an idea how frame is generated. So anyways, we are not going to generate any frame. It will be done automatically for us by the built-in UART block. We are just going to configure that block and that block is doing everything for us. It is sending the start bit, data it is sending, parity it will calculate for us, and even it will generate a stop bit also. I hope you are understanding my concern, Munir. Yes, that is for sure, Prakash. At a one instant, you can transmit a one stroke, you can transmit 8 bits only. So if you have 100 bits, 888, you have to keep transmitting. Still, your data is what? Completed. No other option because frame format is like this. Fine. Okay, now I want to introduce few more things. What are those? Now data part, what they are saying, data part can be 5 to 9 bits. You are having either 5 to the 9 bits. But people, if you see this frame format, 5 bit is okay, but how many total data bits are you able to see in this frame? How many total bits you are able to see? 8 bits, right? Then how can we transmit a ninth bit? If I want to do the 9-bit transmission, how can we do that? So for that, if you are planning to do the 9-bit transmission, then you have to compromise the parity bit. If you want to do the 9-bit transmission, then this is going to be your ninth bit. So instead of parity, you are using that bit for the transmission of the 9 bit. So your data part can be what? 5 to 9 bits. Okay, then okay, stop bit as I said could be 2 bits and parity could be either 0 or either 1. So this is about your UART frame format. So if you still have any queries, when we open a data sheet and when we do the actual programming, that time we will see those. Fine. Shall I proceed further, people? Okay, now next slide is about the baud rate. So what do you mean by baud rate? Baud rate is nothing but number of symbols per second. So whenever you're talking about the baud rate, then what? It's nothing but how many symbols we are transmitting per second. But people, if you see this UART communication, what are we going to transmit? What is my symbol? Don't you think my symbol is nothing but the bit? Very good. So here what happened? In this context, what happened? Symbol is nothing but bit. That's why sometimes it is also referred as a bit rate. But usually what is a bit rate? It's nothing but number of bits per second. And what is a baud rate? Symbols per second. So in this case, my symbol is bit. That's why you can refer baud rate also as a bit rate. But what is a baud rate? Baud rate is nothing but the frequency of data transfer, how many bits you are transmitting in this case. And guys, last very important point, both transmitter and receiver has to agree upon common frequency for the data integrity. Both your transmitter and receiver must have a same baud rate, must have a common frequency. If it is not, then you will get the corrupted data. Now let me show you this. Now see this example. So you see this is device 1, this is device 2. Okay. Now let's say both are having different baud rate, different frequency of data transmission. So device 1, this green color lines is for whom? For the transmitter. So device 1 is what? Transmitting the data, and device 2, let's say, receiving the data. Now people here, these devices having different data rate. Now let's assume device 1 is transmitting 1 bit per second. Oh, I'm so sorry, not 1. Let's say it is transmitting 2 bits per second. Okay, how many? 2 bits per second. And let's say device 2 is receiving 1 bit per second. So almost frequency for the device 2 is 1 hertz, and for the device 1 is 2 hertz. 2 bits are transmitted per second, 1 bit is transmitted per second. Okay. Now see how this communication is going to happen. So what happened, people? What happened? So this device 1 transmit the start bit first. So how much time it will take, people, to transmit just a start bit? For 2 bits, it's a 1 second. For a 1 bit, how much time it will take? It will take half second, 0.5 second, right? To transmit a start bit, it will take a half second, okay? So within half second, device 1 will transmit the start bit. So what happened to the device 2? It will start receiving the stop bit. But to sample this, did I just say stop bit? I'm so sorry. So what device 2 will do? It will start receiving the start bit. But to sample the start bit, to receive the start bit, how much time it will take? Literally, it will take entire 1 second. So within a 1 second, it is going to receive the just a start bit. But by that time, what happened? Device 1 will end up by transmitting D0 also, right? In next half second it is transmitting D0, but since device 2 is what busy in receiving start bit, it will miss the D0. Okay. Then for a next second, device 1 is transmitting D1. Again it will take half second to transmit it. And device 2 will say, I just received the start bit, and for me it is a D0. So it is considering D1 as a D0 and start accepting it, and again it will take a 1 second. So within a second again it will transmit the 2 bits. Again D2 is missed here. Again for a next 1 second it will transmit a D3, and it will consider that as a D1, and it will take 1 second to understand this bit, and by that time it will end up by transmitting D4 also. It is missed. Now people, don't you think due to this different baud rate, different frequency of data transmission, after every second we are missing one bit, correct? Like this way, and this is how data is received in the device 2. So is this correct data, people? Whatever data received by the device 2, it is correct data. That's what device 1 wanted to transmit. No, it is what? Corrupted data. Understanding, it's what? Corrupted data. So I hope you got my point. I hope you understood the point number 4. Why both the devices has a common frequency. Clear? With this point, it's very important. While doing programming, we have to take care both your transmitter and receiver is having same frequency. Understood, people? Clear? Now, next slide is about the difference between baud rate and bit rate. So guys, what we saw, sometimes we refer baud rate as a bit rate also. But let's see what is the difference between baud rate and bit rate. So guys, what happened in case of baud rate, particularly if you're talking about the baud rate, you see here, these are the bits, and this is what? Timeline. It's in the millisecond. What happened per instant? In case of baud rate, only one bit is transmitted per instant. You see the waveform 1 for the baud rate. Per instant, after every 100 millisecond instant, one bit is getting transmitted. But in case of bit rate, you can transmit multiple signals per instant, multiple bits per instant. Now it might be what some modulated signal possible. So let's say I have a modulated signal for some voltage levels. I'm transmitting that. Means for example, let's say uh, 0 volt. I'm considering the modulated signal as a 0 0. Then 1 volt as a 0 1. And 2 volt as a 1 0. 3 volt as what? 1 1. Like this way. I have some modulated signal and I'm transmitting that. Okay. So what happens if you see here? In case of bit rate, what happened? I'm transmitting how many bits per instant? 2 bits per instant. Okay. So guys, if you see per second, in first case, how many bits are getting transmitted per second? Here 1 second will be finished. After a second, in first case, how many bits are getting transmitted? Count now. How many bits are there? One, two, three, four, five. How many bits are there? 10 bits are getting transmitted. But in case of second case, how many bits are getting transmitted? 20 bits. So guys, to summarize, I would say, what is the difference between baud rate and bit rate? If somebody is asking you, you can say, in case of baud rate, what happened? Only one bit can be transmitted per instant, just a single bit. But in case of bit rate, you're having multiple bits per instant. And in case of baud rate, there is a just one bit per instant. This is what basic difference between the baud rate and bit rate. Okay. So anyways, in this case, in this context, we are referring baud rate as a bit rate also because we are transmitting bits per second. Okay, so fine. So this is about the UART theory. That's it. This much knowledge is more than enough to do the programming of the UART protocol. Understood, people? Clear? So any query, any doubt here? Baud rate is used here. Baud rate is frequency of data transmission. Baud rate is the common term. Okay, let me give me the last point and then I will come to your question. Prakash, by that time you can pose the question, okay? What is the question regarding frame format? May I know? You can post it. Okay, so people, now what happened? Generally, when you do the UART testing, so it happened between two different systems. So you can see this is your host and this is your device. So let's say this is your target board and this is your PC or this is your laptop. So what happened? So whenever you do the UART testing, so there is what physical connection, wiring is there, wired connection is bit there between these two devices, and then via these wires there is interconnectivity between these two boards, between these two systems, between your PC and between your board. But guys, in this case, in our case, what is our target board? Which board we are using to do the UART communication? Which board we are using? You can use your PC, yes you can use, but what is your board? I'm not asking microcontroller. Which board? Guys, are you agree with Munir? Which board? Oh, now you're giving me heart attack. Vinayak, ESP32 we are using, is it? Then what Munir is saying is correct. What it is? What is this? No, I'm asking, okay, you're talking about image, what is there in the slide. Let's not go in that. I'm asking, what is our board? Our board is nothing but, our target board is nothing but PiximLab board. Yes or no? Agree? So guys, so to do the UART testing, so in this case, we are going to communicate between your PC or your laptop or between the PiximLab. But guys, question arises, how is PiximLab going to interact with the computer now? So in real scenarios, in this board, you might be having what? Wired connection directly, but here you're having what? This simulator board. So how this PiximLab is going to interact with this computer? Yes or no? So guys, in order to achieve this, you're getting my question, guys. You're understanding my question. So there is no physical wiring. We are not having wired connection here. Then how this PiximLab is going to talk or going to interact with your PC or interact with your computer? So guys, in order to achieve this interaction, we need to install null modem emulator in our PC. So I think we did the installation in the last class. So that's why we installed this null modem emulator in our PC. So what happened? So this null modem emulator is going to act as a bridge between your PiximLab and between your PC, between whatever serial port is there in the PC. So it's a kind of what? Virtual port which we are using to interact between these two applications. So that's why we need to install we need to install this null modem emulator. Understood? Why did we install this null modem emulator? Clear, everybody? So it's kind of virtual connection, virtual port pair we are using to connect what? PiximLab and to connect our laptop, our system. Okay. So again, when I show you the demo now, that time you will get the more clarity. Fine. Okay. So what is your question, Prakash? I'm still waiting. You didn't posted anything. Are you there, Prakash? We all are waiting for your question. Okay, how many bits we can transmit? We can transmit from 5 to 9 bits. Minimum count is 5, maximum count is 9 bits. But when we are transmitting 9 bits, that time you can't use the parity bit. Instead of that, it is used to transmit the ninth bit. Okay, fine. Any other query? Anyone? Okay, so programming we will see tomorrow. So I need a complete at least 1.5 hours for programming. So two programs are there. One is for the polling method and one is for the interrupt method. So both template codes we are going to see. So I can understand few dots you might be not able to connect right now by using this theory. So tomorrow we will see the programming coding part. So if it is clear, then it's a good, and if still you are having any doubts, I will address those tomorrow. Fine? Fair enough, everybody? Okay, so can you please now open your QR scanner, everybody? I will take your attendance, then you can do the session. Okay, you want to take the screenshot? Okay, so nothing much, Aniket. So just you can see, oh, yeah, yeah. From here you can tap. Once you are done, let me know. So guys, do attend this protocol sessions. A few companies are there. Those are hiring even especially on protocols also. So it will help you. And I hope you all are applying for placements. I hope everybody is applying for placements. And do attend the mock interviews. Give your mock interview seriously. If you have any mock interview scheduled, prepared well and give it. So if you're not clearing the mock interview, I think you're not allowed to attend the placements. Still you are clear. So be serious and give all the mock interviews, whatever is scheduled for you. Okay. Common points means what, Aniket? Whatever base I created, okay? Whatever base I created, synchronous or synchronous, modes we discussed, these are some common points. Those I covered first. And then we are going to see UART support which out of that, SPI support which out of that. So even Aniket, if I'm going to mention a common point right now, so do you know rest other protocols? You just saw the UART. That is just a theory you saw, right? So programming is still pending. So you don't know how SPI is working, you don't know how I2C is working, you don't know how CAN is working. So even if I'm going to list out the common points right now, it is going to make any sense to anyone, guys?